questions from last time? Does anybody have any questions from the last homework assignment? No? Okay, that's fine, no big deal.
Wait, can you go over one from like
Name it, dude. We can do one.
like 1 through 10?
Well, I'm not gonna do all 1 through 10. Just
No, I mean like pick any one you want from
you
there.
pick it.
All right. Can you do like 2, like 6, 2, 6, or 8? I'm giving you options here.
Alright, let's do 6. Alright. So, 6 is a little unusual in that we got this extra set of parentheses going on here. So it's kind of violating, we're going to have to kind of violate, we're doing one of two things. We'll either violate the order in which I had kind of given you to do the properties in, or you can do a little simplifying and then use the order. But really what this is here is there's like an extra set of parentheses here that are there that they didn't write. So I can either think of this as using my exponent property, like doing that. Right? Remember our properties from exponents from last chapter? When you have the exponent of a fraction. This is probably the way that I would have thought about it, is I would do this first. And then I could do my quotient property. And then my power property. I think would be the kind of the most natural way to think about that one. And there's my final answer there at the bottom. Is that okay, Walter? Okie dokie.
Can you do one from the other side?
Yeah, which one do you want to do, man?
Kind of 16, 18 messed me up.
Which one?
16 and 18 messed me up, so you can do either.
Okay.
Or 23. 23.
23?
Yeah.
Okay. So when we're doing the compressing, the first thing we want to look for is the power property. So what I'm looking for are coefficients. So I have a coefficient in each logarithm. So the power property allows me to move those coefficients to the exponents. And then the next thing I look for is product properties. So for a product property, when condensing, I'm looking for an addition sign. So I got one of those. That's going to turn into that. And that's a single logarithm, right? We got rid of everything, so I'm just done right there. So there's nothing more to do. So this is my final answer right here. Yes, Chris. 20? Sure. So again, the order for condensing, we're doing power, then product, then quotient. So the first thing I'm going to do is look for power property. So I see one coefficient. So the power property allows me to move that coefficient into the exponent. Then next thing I look for is product properties. So there I'm looking for addition. There's no addition going on. So there's no product property to do. The last thing I'll do is look for quotient properties. For that, I'm looking for subtraction. I do see subtraction. So that's going to be the natural log of x over y to the fourth. And that's going to be my final answer. Is that okay? Yeah, no problem. Okie doke. Anybody else before I move on? Alrighty then. Today we're going to be talking about solving and there's two types of equations that we're going to worry about trying to solve. We're going to look at exponential, and then we're also going to look at logarithmic. All right. So let's look at some examples here. So we'll do exponential first. So maybe we have 4 to the x minus 3 equals 8 to the x plus 1. So one type of exponential, one type of way to try to solve an exponential equation like this would be when we have just one exponential on each side like this, is to try to rewrite them so that they have the same base. So right now, one of my numbers is base 4, the other number is base 8. But what do we notice about both of those numbers? 4 and 8. They're both powers of 2, right? 4 is 2 squared, 8 is 2 to the third. Do you guys agree with that? So what I can do is I can replace 4 with 2 squared, and I can replace 8 with 2 to the third, and now I have like an exponent of an exponent. You should remember from last chapter that when I have an exponent of an exponent, the exponents multiply. Everybody okay there? So when I distribute through, I have this. Everybody still follow? Okay. So, I have these two things that have to be equal. The bases are the same now. They're both base 2. The only way these two things can be equal is if the exponents are also equal, right? Does everybody follow that? Should be relatively obvious at that point. Like, if instead of variables in our exponent, if I have 2 to the third equals 2 to some power, obviously the power on the other thing has to be 3, right? If they're equal, it's just the bases are the same. So I can do that. So I subtract 3 from both sides to get -9, and I subtract 2x from both sides to get x. And so I got that. Is everybody okay there? So the natural question here would be, okay, Mr. Gulick, but what if it's not possible for me to rewrite them or rewrite the exponentials so they have the same base? Yes, Walter.
I got lost. Like for the 8, I get like how you. Oh, is that 3 from 2 to the third power to 8?
Right.
Okay. And then you just what's it called? Distribute it to the exponent.
Correct. So exponent of an exponent multiplies.
Okay.
Right. That was one of the exponent properties from last chapter. So I multiplied the 3 to the x plus 1.
Okay.
So it has to distribute through the whole piece.
And after that, the 2 just.
Well, if those two things are equal and the bases are the same, the exponents also have to be the same, right? If two things are equal, so if I have 2 to the third equals 2 to some other power, the only answer for the other power would have to be 3, right?
Mm-hmm.
If the two things are equal together and the bases are the same, the exponents also have to be the same.
Okay.
So that's the reasoning that we made there, to just forget about the 2's.
Okay.
Okay. But what do I do if I have a situation where it's not obvious, or it's not, not practical to rewrite the two exponentials to have the same base like this? 4 to the x minus 3 equals 6 to the x plus 1. There, if I do a prime factorization, they're not the same base exponential, right? I can't rewrite them both as base 2 very easily. Everybody agree with that? So what should I do here? In this case, I'm going to use a logarithm. Okay? So the question becomes, which logarithm do I want to use? Log base 2, log base 1/2, the common log, the natural log, something else? Well, the short answer of it is, it doesn't matter which log you use. But you can make your life a little simpler by choosing a logarithm that's the same base as one of the two exponentials. So the best case here would be to use either log base 4 or log base 6. It doesn't really matter which one of those two you use, but it probably becomes a little bit easier if you use an exponent or a logarithm whose base matches one of the exponentials. But it doesn't matter which one. Everybody okay with that? So for the sake of argument, I'm going to use log base 4. Everybody so far so good? Yes, Walter?
Wait, how can we use log again? Is this just another way to do it? Or is this a whole different?
So this problem, can I rewrite 4 and 6 as the same base exponential?
Yeah.
No, I
No?
cannot. Right? 4 is 2 squared, 6 is 2 times 3. They're not both powers of the same number, right? So that's why I have to do something different.
Okay.
Is that okay? So we had talked before that a logarithm base b cancels an exponent base b. So on the left-hand side, the log base 4 cancels the exponent base 4. And I'm just left with x minus 3. Everybody okay there? That was one of the big key ideas from 2 lectures ago, or 2 lessons ago. And we're going to use this idea quite frequently in some of these other solving problems that we're going to look at today. Are we okay so far? Now, in my right-hand side of this equation, the log base and the exponent base are different. Everybody agree with that? So they will not cancel. What I'm going to use instead is the power property. So the exponent in that logarithm, the x plus 1, I get to move to the coefficient of log base 4 of 6. Everybody okay with that? So just use the power property there. Now remember, log base 4 of 6 is just a number, right? It's like the square root of 7 or something. It's a big, long, crummy decimal that's really long and gross and doesn't make a lot of sense, but it's just a number. Everybody's okay with that? That log base 4 of 6 is just, it's some decimal. It's like 1.2375961, yada, yada, just some big, long decimal. Doesn't matter to us right now what that number is, but we need to remember that it's just a number. It's not a variable. It's just a number. It's like the square root of 2. Everybody's okay? So what I'm going to do here is I'm going to distribute that number through the parentheses. So x times log base 4 of 6 is just log base 4 of 6 times x, right? Everybody's okay there? And then we have plus log base 4 of 6. So if it helps, if it makes your life easier, you can turn that log base 4 of 6 into a number. You don't have to do it here. You can just hang on to the symbol all the way into the end, but I know some of us are more comfortable turning things into a decimal. So maybe we could round that number and call it 1.292. Don't just freeze on me. Sure looks like it. Stupendous. We're off to a good start today. Let's try this again. So we can move now things onto the same side. So maybe I subtract x from both sides. So 1x minus 1.292x just becomes 0.292x. If I subtract 1.292 from both sides, negative 3 minus 1.292 becomes negative 4.292. And then if I divide both sides by 0.292, I get negative 14.699. Is that okay with everybody? What if we have a situation like this? Let's say I have negative 3e to the 2x minus 5 plus 6 equals negative 12. So reminder, the e in this equation, is that a variable? No. Remember, that's that number, like 2.72 or whatever. Right? So, got to remember that's just a number. So this problem, there's only one exponential, right? Instead of having two exponentials like the previous examples. You guys see that? So this is going to feel quite a bit more like a normal solving problem to you. So the first thing I would do is try to get the exponential part by itself. So I'm going to subtract 6 from both sides. Everybody okay there? And then divide both sides by the negative 3. Everybody okay there? Now I have to get rid of that exponent base of e, because again, there's not a good way to rewrite e and 6 to have the same exponent base. We're kind of in the same spot we were in the previous problem, right? So what should I do to get rid of that exponent base of e? What did we do to get rid of the exponent base of 4? We used log base 4, right? So what should I use to get rid of exponent base of e? Log base e. But remember, log base e was one of those special symbols, right? You can write log base e, it's not wrong. But what log base e, the symbol that we use is the ln symbol. So the log base e cancels exponent base e. And remember, the natural log of 6 is just a number, right? That's a number we can type into our calculator and get the decimal for. Again, it's just a long crummy decimal. So you could leave that as the natural log of 6, or you can turn it into a decimal. Probably most of us would feel more comfortable if I went ahead and just typed that into my calculator. So that's about 1792. Everybody's okay with that? Then I can just add 5 to both sides. And then divide both sides by 2. And I get 339.6. Does everybody feel okay with that? So those are the three different kinds of exponential equations that I would expect for you guys to be able to solve. So again, you have a situation where you have two exponentials, but you could write them as the same base. Now keep in mind here for this example A, we could have done the same thing that we did in example B and used the logarithm there. That would not be wrong. It'll still work out to give you the same answer. You could do that as well. If you're like, hey, I'm just going to use logarithms on both of these things, that's okay. Is everybody good with that? The second example, you have two exponentials set equal to each other that cannot be written as the same base easily. I mean, they can, but it's going to be like some kooky whatever, some kooky number that you don't want to mess with. And then the third type is where we have just one exponential. Everybody feel okay on those? Let's talk about logarithmic equations then. Yes, sir. Of course. Freeze. Okay. So let's say we have this logarithmic equation. 2 times log base 3 of 2 minus 3x plus 3 equals 7. So the plan here for an equation like this, where you just have one logarithm in it, is going to be to get that one logarithm by itself on one side of the equation. So I'll start by subtracting 3 from both sides. And then I got to get rid of that coefficient in front. So I'll divide both sides by 2. okay to here. Now I got to get rid of this logarithm. What cancels out a logarithm? Again, this is the big key idea from 2 lectures ago. So remember how a logarithm cancels out an exponent base? What do you think is going to cancel out a logarithm? Oh, guys, come on. So like multiplication cancels out division, right? Everybody agree with that? So what's going to cancel out multiplication? Division. So if a logarithm cancels out an exponent base, what cancels out a logarithm? An exponent base. Everybody agree? So the question becomes, what base should I use? What exponent base, what number should I use as my exponent base in this particular problem? Do I want to use 2? Do I want to use 1.6? Do I want to use 21? What number would I want to use? It should be obvious. You want it to match the base on your logarithm. So we should use 3. Now I'm going to write that 3 really big to remind myself that I'm not multiplying by 3. 3 is an exponent base, so whatever was there is now in the exponent. Everybody's okay with that? So again, the exponent base is going to cancel out the logarithm. And 3 squared is just a number. That number is 9. Everybody still doing okay? So now I'm going to subtract 2 from both sides. And then divide both sides by -3. But I'm not done. Unlike exponential equations, the ones we just got done solving, logarithmic equations can have extraneous solutions. So we do need to make sure that we're checking our answers, because we'll get some answers that are extraneous and don't actually work. The check, though, is very easy. All I need to do to check this is I need to take my answer, or answers if I get more than one, and plug it back inside the logarithm in the very beginning equation. And whatever is inside there just has to be positive. So it just has to be greater than 2. So if I take -7/3 and multiply it by -3, I get 7. So 2 plus 7 is 9. That's a positive number, so this is A-OK. That answer is fine. Everybody okay with the check? Again, you can plug it all the way in and make sure the 2 sides are equal, but that's more work than you need to do. All you need to do is make sure that what you're plugging into the logarithm is positive. It results in a positive. Let's do another. freeze again? Looks like it. This is very frustrating. This didn't happen at all yesterday. I think it's just your class is cursed. Who's cursed my OneNote? One of you must have done it. It was Frazier? It's a jerk move, Andrew. Don't do it again. Undo the curse. Okay. Here's another logarithmic equation. What do you notice that's different about this one than the first one? Yeah, Becker.
There's 2 logarithms.
2 logarithms, that's exactly right. So we have to do something a little bit different than we did in the first one. My goal, first things first, is to get 1 logarithm in this problem. So basically, what I'm going to do is I'm just going to take these 2 parts and just try to condense them. Everybody's okay with that plan? So, neither of them have a coefficient, so there's no power property to do. I do see addition, though, between them, so I can do the product property. Everybody happy with that? And I might as well go ahead and multiply the stuff on the inside together. At some point, I'm going to have to do that. Might as well just do it right now. Okay, now I got to get rid of this logarithm. So what's going to cancel out a logarithm? An exponent base. Very good. So the question becomes, what number do I want to use as my exponent base in this problem? I want to use the base for the logarithm. But Mr. Kulik, there's no number written there as the base of the logarithm. What do I do? Well, if you remember from 2 lessons ago, this is one of those special logarithms that got a special symbol that we don't write the base down for because we've agreed that, like, hey, this one comes up a lot, we're not going to write the base down for it. Does anybody remember the number for the base in this situation where we don't write it down? 10 is the correct answer. So I'm going to do the exponent base of 10 to both sides. And the exponent base cancels the logarithm. That gives me x squared minus 3x. And 10 to the first is just 10. What kind of an equation am I left with now? It's got an x squared in it. Starts with a q. Then a u. Then an a. Then a d.
Quadratic.
That's the answer I'm looking for. We're left with a quadratic equation. To solve a quadratic equation, we have to first get it equal to 0. So I'm going to subtract 10 from both sides to make it equal to 0. And then my OneNote's going to freeze. Andrew,
Yeah, that's my address.
it's not doing it. I asked you once nicely. I'm not going to be so nice the next time. Okay. And then to solve the quadratic equation, we can either use factoring or the quadratic formula, are the two major methods that we've discussed. If it's me in a situation where the leading coefficient is 1, I'm going to try to factor first because if it works, it's going to be easier than the quadratic formula. But I know that it might not necessarily work and I have to use the quadratic formula. Okay? But I'm going to try at least. So multiplies to give me negative 10. Adds to give me negative 3. What two numbers do that? Negative 5 and positive 2. So there's that. Then using the zero product property, I can set each of these equal to 0. So the solutions I get are 5 and negative 2. But I'm not done. What do I still have to do? You gotta check. So if I take 5 and I go back to the very beginning, if I plug 5 in for x, that's a positive number. And then I plug 5 in for x here, 5 minus 3, still a positive number. So 5 is a good answer. I'll keep that one. Next I'm going to do negative 2. So if I plug negative 2 in for x, in the first log I get negative 2. Uh-oh! That's not positive, right? So does it matter what happens in the other one? Nope. Just going to cross it out. It's extraneous. I don't care. Everybody okay there? I think one more situation that I want to talk about here, and then we'll be done with this idea for today. Let's say that we have the natural log of x plus 5 equals the natural log of x minus 7. What's different about this problem than the previous problem? Notice they both have two logarithms, but this problem doesn't also have a constant that's not a logarithm, right? Everybody see that? The other one has, or the other problem has this 1. It's not inside a logarithm. Here, everything is inside a logarithm. Everybody agree? That's actually good news for us. Because as long as the logarithms have the same base, we can just forget about the logarithms. The same idea if I had two, like when we forgot about, let me go back and show you. It's really the same idea. Remember right here where we just forgot about the exponent base of 2? Because we had two things that were equal. The same idea here with this problem that we're looking at. Because the two logarithms are equal, that means the stuff inside the logarithms also has to be equal. Provided that they're the same base logarithms, right? If one of these was natural log and the other was common log, you couldn't make that. You can't do that, what I just did. Is that okay? All right. So, from here, it's very easy, right? I can subtract the x over to make 2x and subtract the 5 to make negative 12. And then I divide both sides by 2 to get negative 6. But we're not done. What do we still have to do? Check. When I plug negative 6 in for x, 3 times negative 6 is negative 18, plus 5 is still negative. Ruh-roh raggy. That answer is extraneous. What do I do now? I don't have any answers left. Just write no solution. Because all my answers are gone. Cross them all out. There's no answers left. Oh no! It's okay. What do you guys think? So I'm going to write you guys up a